Today we'll explore decentralized and self-sovereign identity, a shift from platforms own your account to you own your identity. You'll see how users can hold credentials themselves, share less data, and reduce dependence on any single provider, while still meeting real-world security and compliance needs. Most digital identity today lives in centralized silos, banks, platforms, even governments that own your account. That model worked at small scale, but it breaks under modern pressure. It creates giant breach targets, locks users into specific platforms, enables broad cross-service tracking, and clashes with emerging privacy regulation. This module looks at what comes next. Self-sovereign identity flips the traditional model. The individual becomes the organizing center, not the organization. First, user control and consent. You decide which identifiers exist, who can use them, and you can revoke access instantly. Second, minimal disclosure. You can prove claims like "I'm over 18" without exposing your full birth date. Finally, portability and interoperability ensure those credentials work across devices, wallets, borders, and vendors, so identity becomes reusable infrastructure instead of another silo. Now let's position self-sovereign identity against the models you already know, across 4 strategic dimensions. In centralized identity, platforms hold full control. Breaches are catastrophic. Users are locked in, and data can be hoarded for AI profiling. Federated identity shifts some control to an identity provider, improving convenience but still concentrating risk and data. Decentralized or self-sovereign identity moves control to the individual, localizes breach impact, enables true portability, and uses cryptographic proofs to resist large-scale AI profiling. Decentralized identifiers, or DIDs, are a new kind of identifier you can own yourself, without depending on an email provider, platform, or government registry. A DID looks like a simple string, but each part has a purpose. The DID scheme tells software to treat it as a decentralized identifier. The method name points to the rules and infrastructure for resolving it. And the final part is a cryptographically generated identifier, bound to keys you control, enabling secure, verifiable interactions across systems. To make decentralized identifiers actually useful, 3 steps occur. You start with a simple DID string. On its own, it's just an ID. Software then resolves that string into a DID document. The document lists public keys for verifying signatures, plus service endpoints for where to send encrypted messages. Finally, the document is anchored on a decentralized network, so its history is tamper-evident and not controlled by any single provider. Verifiable credentials rely on a straightforward trust triangle. An issuer, like a university or bank, creates a credential and signs it with its private key. You, as the holder, keep that credential in a digital wallet and decide when to share a proof. A verifier, such as a landlord or another app, checks the proof using the issuer's public key. The issuer and verifier never need direct contact. Trust is enforced mathematically. That same trust triangle becomes more tangible when you look at everyday roles. Issuers create and vouch for facts about you. A government confirms your citizenship, a bank your KYC data, a university your degree. You, as the holder, collect these credentials in your wallet and choose when and where to present them. Verifiers then rely on them. A border agent, an employer, or an online service deciding what you're allowed to access. Digital identity wallets hide almost all of the underlying cryptography, so users only see familiar cards and buttons. But 2 lifecycle flows really matter. First, seamless updates and revocation. Issuers can silently flip a credential from valid to revoked, and verifiers see that change in real time. Second, secure key recovery. If someone loses their device, recovery methods must be strong enough to resist attackers, yet simple enough that people can actually complete them. Here's the key shift in how data flows. In a traditional centralized model, platforms ask for rich raw data, like your full birth date, then feed it into AI profiling engines that infer far more than you intended to share. With self-sovereign identity and zero-knowledge proofs, that logic reverses. You reveal only the specific fact the service actually needs, say that you're over 18, backed by strong cryptography. I still gets enough signal for a decision, but not a surveillance-grade dataset. Self-sovereign identity gives users more control, but it doesn't magically remove AI risk. Think again in terms of the trust triangle: issuer, holder, verifier. AI can impersonate people to fool issuers during onboarding, using deepfake documents and liveness attacks. It can socially engineer holders with hyper-personalized phishing to steal wallet recovery secrets. And bots can flood verifiers with synthetic claims, overwhelming reviewers, and probing edge cases. You need defenses across all three sides, not just strong cryptography. Strong cryptography is necessary, but it isn't sufficient for digital identity to work at scale. Three layers have to move together. Technical standards make different systems speak the same language. Trust registries define which issuers and credential types are actually recognized. Cross-ecosystem rules determine who's liable, how disputes are resolved, and how regions bridge regulations. When these align, you can accept a credential from somewhere you've never heard of and still rely on it with confidence. Self-sovereign identity offers a rare win-win. It can satisfy strict privacy regulations while actually collecting less data. Because credentials live with the user, organizations only request the minimum proof they need, using techniques like selective disclosure or zero-knowledge proofs. You can prove you meet a rule, align with GDPR or eIDAS, and still avoid building giant, hack-prone data silos. Think of it as accountability without mass surveillance. Self-sovereign identity gives users a powerful inner shield. Your data sits in your wallet, not in giant AI training silos. DIDs and verifiable credentials let you share just enough information, with strong cryptographic proof and portability. But that inner layer alone isn't enough. Around it, you still need governance and AI defenses to absorb new threats: deepfakes, automated phishing, corporate data extraction. The winning strategy combines SSI with robust rules, monitoring, and response. The future identity ecosystem shifts control to users, with consent and minimal disclosure as defaults. Cryptography replaces phone-home checks with verifiable exchanges. AI is both shielded against and weaponized, demanding advanced defenses. And none of this operates at scale without strong, interoperable governance and clear accountability tying it all together.